Welcome to Secret Squared. I'm Cassie Secret. I'm Megan Secret, and today we're going to continue our series on factoring, and we're going to talk about factoring trinomials. So let's dive in. So for us to factor trinomials, there's a few things that have to happen for us to actually use this method. First things first, for us to be able to factor a trinomial, it has to be a trinomial. And what a trinomial is we have to have three terms. Now, a way that I like to remember this, we have mentioned in previous videos the term binomial. A binomial is something with two terms because a bicycle has two wheels. If we're talking about a trinomial, if you think a tricycle has three wheels, which is why this one is three terms. And besides just the fact that it has three terms, it can't be any three terms. It has to have a specific form. So it's going to be of the form ax squared plus bx plus c. Now, a, b, and c are stand-ins for any number. Now, one thing I also want to add, we put x here. It could be any variable. It could be y, it could be n. It just has to be the something squared and then that term on its own. Exactly. Now, what that might look like. So, for example, some things that meet this criteria would be like x squared minus 4x plus 3, x squared plus 6x plus 7, or 2x squared plus 5x plus 3. All of these have three terms and are of that specific form. Something that wouldn't work would be, so this would not work, would be something like 2 plus 3x plus 5. This is a number. This is something with that x term, but this is just a number. It is not something with an x squared, so we would not say we could factor this like a trinomial. So for us, as we go through the steps for factoring a trinomial, we're actually going to do it alongside an example. It's going to make it a little bit easier to see all the steps that happen. So for our very first step, we're going to look for GCF. And actually, anytime you factor ever, you always need to look for a GCF first. If there is a GCF, you need to take it out. So looking right here, first of all, we have three terms. Of the three terms, they do not all have a variable, so we can't take a variable out. We have a 1 in the front, a -4, and a -5. Because we have this 1 as the very first coefficient, actually the GCF is just going to be 1. So because our GCF is 1, we actually don't have to do anything with it because if you try to divide out that GCF, if you divide by 1, you're not going to change anything. So we still check for the GCF, it's 1. It doesn't really impact our answer much. We're going to keep going. So for our next step, what we want to do is we want to identify what our values are for A, for B, and for C. And just a reminder where we're getting those from. On the earlier page, we talked about how our trinomial has to have the form ax squared plus bx plus c. So that A is whatever comes in front of the x squared. The B is whatever comes in front of the x. And the C is the number or the constant that's on its own. So looking at this, there's our x squared term. There's no number technically written in front of it, so that is going to be an invisible 1. Because when we multiply 1 by something, it doesn't actually change the value. So A is 1. Our B is the term in front of the x. That's not just the 4, it's actually the -4. So we do have to keep that negative. And that last term on its own is not just the 5, it's the -5. Yep, so I'm just going to go ahead and label that on the side. Our A was 1, our B is -4, and our C is going to be -5. Biggest thing is just making sure you don't miss those negatives that do show up. Exactly what I was going to say. So from there, our very next step, the way that we're going to factor these trinomials is a method that we've learned is called the diamond method. So we are going to set up, they call it the diamond method, but you're going to draw an X. It's really just a nice way of organizing your information. And for that, we are going to put A times C, whatever those numbers are, we're going to multiply them together and put it on the top. Now, in our case, A times C, 1 times -5 gets you -5, so that's going to go on top. And then on the very bottom of that, not diamond, but of like the X, we're going to put the B number. So we don't do anything, just grab the B number. In this case, that's the -4. We're going to put that right at the bottom. And one thing I like to do to remember, because when you're setting this up, it can be easy to mix them up. I like to think that B stands for the bottom of the X, if that helps you use it. And then how this diamond or how this X is going to work goes into our next step. So for step 4, we are going to find two numbers. And these two numbers have to do specific things. The two numbers that multiply to A times C which that A times C is the number that's on top of our diamond or on top of the X, and they have to add to the B number. So something I do is if you want to put little times up here, like numbers that multiply to that, and numbers that add to that. I like to think of it as almost like a little puzzle of finding two numbers that work. Now, just a heads up, sometimes you might have a trinomial where you try this method and you don't find any numbers that work. If so, that means you can't factor it with this method or it might not be factorable. But for just the sake of this video, we're only going to show you ones that do work. And then the one thing is there are a lot of negatives because there's that -5 and the -4. So that's your hint that there's probably going to be a negative that shows up in the side of the diamond or the X. Yep. So we have something that multiplies to -5 and adds to -4. Now, what's helpful is 5 is a prime number, which means the only numbers that multiply to it are 1 and 5. But I know that I need to multiply to -5. So one of these numbers has to be negative. What I like to recommend to do is if you're not immediately sure which one to make the negative, just try one, and if that doesn't work, try the other. So if you tried making the 1 a -1, those numbers do multiply to -5, but if you add them, you would get a +4, and we need a -4. So that's your hint that you need to make the other number negative, so you need a -5 instead of a -1. Exactly. So 1 times -5 gets you -5, and if you add them, that gets you -4. So we found our numbers that are going to work in our diamond. For our next step, we're still going to be working inside that X. We are now going to divide those numbers we put on the side by A. And this is actually one of the most important steps. What we're going to do is our A value is 1. So you are going to take the numbers that you just came up with in your diamond and you're going to divide them by 1. Thankfully, though, since we're dividing by 1, that's just equal to 1. And this is equal to -5, so it doesn't actually change the value. Yep. But so that's getting into our next step, which is our next step whenever you set up those fractions here. Like Megan said, in this case, we had something really nice because we were dividing by 1, but that's not always the case. So a lot of times you might need to divide or to simplify because it might not divide perfectly, it might stay a fraction. Yeah, sometimes you'll have to divide or simplify the fractions. And then once you do that, then you can write in factored form, which will give us our final answer. So from here, what we want to do, our factored form is going to look like you have two sets of parentheses being multiplied together. For this problem, the very first thing in each parentheses is actually just going to be an X. So we have an X and an X. It's going to look like X plus or minus something times X plus or minus something else. Where we're going to get the numbers for the second spots is actually going to be from these numbers right here. So we're just going to grab the 1 and grab the -5. And because since it's a positive one, we're going to end up putting plus 1. So we're not going to change the sign. And then for the other one, we're going to have a -5 because this was a -5. And actually, if you were to take this and multiply it out, you would end up getting the problem that you started with. So that's going to go ahead and be your answer. So for our next example, we're going to look at factoring 3x squared plus 7x plus 2, and we should have the same steps written off to the side just so we can reference them. First things first, just like we did for the last ones, we are going to look for the GCF. Because not all of the terms have an x, we can't take a variable out, but we have a 3, a 7, and a 2. There's actually no number, well, not there's no number in common, but the only number in common between them is the 1. So our GCF is just going to be a 1. And again, when your GCF is 1, you're not actually going to have to divide out the GCF because it's not going to change anything. So for the next one, you're already going to be ready to identify your A, B, and C. Just be careful. Oftentimes, if your question's already written in standard form, your A, B, and C will be in order. However, it's not always, so just double check. The A should be the number in front of the x squared, which in this case is 3. The B is in front of the x, which is 7, and the C is just the number, which is our 2. So just going to label that off to the side. A is 3, B is 7, and C is going to be 2. Always be on the lookout for any negatives that might be there. So now that we have our A, B, and C, we can set up this diamond or this X. So we're going to have, okay, we need the top to be whatever numbers A and C are multiplied together. So we have 3 times 2 gives you 6. And then that B number, in this case our 7, goes right on the bottom. And again, like Cassie said earlier, this is kind of just like a puzzle where you have to figure out now two numbers that multiply to this top number, this 6, and that add to the 7. This tends to be one that throws people off. But if you're ever getting stuck, just think of any numbers that you can that multiply to 6. One very common one is people like to think 3 times 2. Those multiply to 6, but if you add them, that adds to 5, which doesn't work. So then you want to try something different. Besides 3 and 2, 1 and 6 multiply to give you 6, and 1 plus 6 does give you 7. So our numbers here are going to be 1 and 6. And we didn't say this on the last part. That 1 and the 6, you could have flip-flopped them. It doesn't matter which one is on the left and which one's on the right. Yeah. It's just personal. As long as you had both the numbers, that's what matters. So now we have those two numbers. We are now going to take those two numbers, the 1 and the 6, and we are going to divide by a. Because our a was 3, we're now going to have to divide 1 by 3 and divide 6 by 3, which is a little bit different than the last problem where we had a was 1. So the next part is you want to see if you can divide or simplify any of your fractions. Now, 1 over 3, that doesn't divide nicely, and it doesn't simplify either. Simplify is when you're able to find something that divides the top and the bottom number. In this case, 1 and 3 can only be divided by 1, but if you do that, it's not going to change 1/3 at all. So looking at 6 over 3, that one does actually divide, and that just gets you 2. So in this case, the numbers we're really going to be taking, let me use a different color, the numbers that we're going to be taking from our diamond are going to be the 1/3 and the 2. So we have 1 is a fraction, 1 is a whole number. Even though there's a fraction, we're going to do the same steps we did in the last problem. Now we're going to write it in that factor form. And it's going to be x plus or minus something times x plus or minus something else. We're just going to grab these two numbers in that purple. So we're going to have x plus the 1/3 because the 1 over 3 is positive. And then do the same idea, this 2 is positive, so we're going to have x plus the 2. Now what we're going to run into is, in this case, I actually have a fraction in our final answer, and we really don't want to have a fraction written in our factored form. So like a little note that we're going to make, and this is how we're going to be able to get rid of that fraction. If you have a fraction that cannot be simplified, in this case, the 1 over 3, that does not simplify. Earlier, we had a 6 over 3 as a fraction, but that did simplify to give us a nice whole number. So if you have a fraction that can't be simplified, like that 1 over 3, what you're going to do to get rid of the fraction is you're going to grab the denominator or that bottom number, and you're going to slide it in front of the variable. So what that's going to look like for this one, that 1 over 3, we don't want it to be written as a fraction, so we're going to take that denominator or the number on the bottom of the fraction, and we're going to take it and slide it or move it to go in front of the x. So that's going to end up becoming 3x plus 1, and the other parenthesis will stay the same, x plus 2. That 3 will always slide in the x that is within the same set of parentheses. So if this had been like the second set of parentheses, you would always make sure that 3 stays with the x in the same set. And it doesn't matter which order, you could have had it as x plus 2 times 3x plus 1, as long as this 3 is with that 1, and this x is with that 2, that's what matters the most. And then that is going to be your final answer. For our next example, we're going to have to factor 4x squared plus 12x plus 8. We're going to do the same first step. We're going to look for GCF, or what's in common between the numbers 4, 12, and 8. Again, note we are not going to have to take a variable out or have variable in our GCF because of these three terms, all three of them do not have an x. This 8 doesn't have a variable. But if we look at 4, 12, and 8, the GCF, or the greatest number that divides all of them, is actually going to be 4. So we have that our GCF is going to be 4. And then from there, because we actually have a GCF, I'm going to go ahead and slide that over here. Since we have a GCF, we have to divide it out. So divide each of your terms by that GCF, which is 4, which gives you x squared plus 3x plus 2. And you have to make sure that GCF is going to stay on the outside of the parentheses. That GCF, we're not going to have to do much with it throughout the rest of the problem, but this just makes sure that this and the problem we started with have the same exact meaning. So now we've looked for the GCF. We did actually have one that wasn't just 1. We are now going to identify the A, the B, and the C. In this case, go ahead. In this case, the A, we don't have any number in front of the x squared, so it really means we have an invisible 1. So we have, there's our A, our B is the number in front of the x, and our C is the number on its own. Yep, and then what I was going to add is a really common issue is people tend to want to say that the A is 4 because they see, oh, that's the first number that I see. but that 4 is not the coefficient for x squared. So do exactly what Megan did. Make sure you're identifying that there's actually a 1 in front, and that's your a value. So a is 1, b is 3, and your c is going to be 2. Now that we have the a, the b, and the c, also you don't necessarily have to write it out as long as you've identified it. Yeah, if you're feeling comfortable without it, I'm just putting it that way we make sure we're clear on what it is. Now we're going to set up our diamond or that x, and we're going to make sure the top is going to be the number that's a times c. So we have our a is 1, our c is 2. That's going to multiply together to give us a 2. And then our b number, that 3, is going to be the number all on the bottom. As Cass said earlier, the b number, that's your base number, so it goes on the bottom of that x. From here, we just have to find two numbers that multiply to 2. So we put a little times sign to minus multiplies to 2, and it adds to 3. This case, the only things that multiply to 2 are 1 and 2. So let's see, we put 1 and 2 down. Order doesn't matter. So you could have written 2 and then 1. Yeah, it doesn't really matter. 1 times 2 does give you 2, and 1 plus 2 does give you 3. So these are the numbers that we want. Yep. And then from there, you have to divide by your a value. Be very careful. Remember, your a value is not the 4. 4 was your GCF. Your a value is 1. So divide those by your a, which was 1. And in this case, when you divide by 1, those numbers aren't going to change. So 1 divided by 1 is still 1. 2 divided by 1 is still 2. So typically when you have an a of 1, that's going to make the problem a little bit easier. So we're going to have still that 4, and now we're going to have it in factored form. We're going to have two things multiplied together to give us this original trinomial. We're going to have an x as that very first part of, or very first chunk of each of the parentheses. If your problem, instead of using x, used like n or something, then you would use that letter instead. And then we're going to grab the two numbers in here, that 1 and the 2, both are positive. And those are going to just slot into the empty spots. So we have x plus 1. Now we have x plus 2. Yep. And then just always make sure, we already did here, but make sure you're including your GCF if you had one. You have to have it as part of your answer. And that's going to be it. Now, for our last example, we actually included a problem that has something you want to make sure that you're looking out for. This looks like a trinomial, just like we've been working with. However, our first term actually has a negative in front. And I just want to make a little note. And this is actually very, very, very important. Your leading coefficient, or that number in front of the x squared, exactly, that number, it must be positive for you to be able to use this method. So if you're seeing that negative, that doesn't mean that our method won't work. What it actually means is you're going to have to factor out that negative. So for us to factor it out, that just really means we're going to divide out a -1. So we're going to divide all the terms by that -1. Now, in this case, the GCF of -6, -5, and -1, 1 is the only thing in common, so that's why it's still a 1. But we are taking that negative out, which is a little bit different than what you might normally see. So the GCF is just 1. We're dividing by -1 instead of just 1 because we also want to get rid of that negative or have it not with that x squared anymore. So we're going to have that -1 multiplied in the front because that's what we're dividing out. So we're going to put the GCF in the front of our parentheses. And then really, since we're dividing by 1, we're not changing the numbers, but we are going to be changing the signs because it's a -1. And then all of them are actually negatives times negatives, so they're all going to turn positive. So now we're going to have a 6x squared. Now we're going to have a plus 5x and a positive 1. Yep. So again, it's really just taking all of those signs and flipping them. If these numbers had something else in common, like if they all had 2 in common, then it'd be a -2 on the outside. Now from here, everything that's in the inside of the parentheses, we can go ahead and factor just like we were doing before, now that our leading coefficient is positive. So we're going to identify the a, so that's the number in front of the x squared. In this case, it's the 6. Our b, we have that number in front of the x. And our c, in this case, the 1. I'm just going to write that off to the side. So our a is 6. Our b is 5, and our c is 1. Now that we have the a, the b, and the c, we can set up this x or this diamond. And really, it's kind of just like a puzzle. So we need the top number to be whatever a times c is. In this case, we have 6 times 1. So we're going to put a 6 on the top. And that b number is that base number on the bottom. So we're going to put a 5 on the bottom. And we're looking for two numbers that are going to fill these spots that multiply to the 6 and add to the 5. Now again, if you're not immediately sure, just start thinking, okay, what multiplies to 6? So ignore the bottom number. Now 1 times 6 multiplied to 6, but those would add to 7, so that doesn't work. So another option is 3 times 2, and oh, those do work, because 3 times 2 gets you 6, and if you add those together, you're going to get 5. So now that we've found our numbers that work, we need to divide by our a value. Now, be careful, this -1 out front, that's your GCF. Don't look at that, don't use that. Our a is the 6. So I'm going to divide both of them by 6. Now, in this case, our fractions, we are actually going to be able to simplify both of them. Our first one, 3 over 6, you can actually divide the top and the bottom by 3, which gets you 1/2. And then on the right, we have a 2 over 6. We can't take a 3 out, but we can divide a 2 out. When you're simplifying, a common question that sometimes people ask is if both of the fractions have to be simplified by the same number, and the answer is no. So this one we divided by 3's, and that one we divided by 2's, and that's okay. So now we're really going to be looking at the fractions 1/2 and 1/3. And this is the first time we've seen both of them be fractions. That is totally fine. And now we're going to want to put it into factor form. So we're going to have that -1, and we're going to have two things multiplied together. We're still going to have x as that very first term. And then both the 1/2 and the 1/3, they're both positive. So we're going to have x plus 1/2, x plus 1/3. Order doesn't matter. And then from here, if you're ever at the end and you have fractions, this is when we're going to use that note that we made earlier, and you need to take anything on the denominator or whatever numbers on the bottom of your fraction and slide it in front of your variable. So that would become 2x plus 1, and the other would become 3x plus 1. And just don't forget that GCF in front. Still need to keep that. So this is actually going to be our final answer. Thanks for watching. If you enjoyed this video, please like and subscribe. If you have any other topics you want us to cover in later videos, leave us a comment below. We'll see you next time.